Hello again. We are in the fifth week. This is the third lecture. Last class, I introduced you to the basics of logic. We saw propositional logic, predicate logic. I gave you propositional logic mainly as a recap and as an entity to introduce the logical connectives: negation, conjunction, disjunction, implication, and equivalence. The logic that we will be using throughout logic-based testing would be predicate logic. So today what we will begin with is to understand various coverage criteria in terms of logic, like we did for graphs. Now we will focus on logic. And as I told you, we will work with predicates and clauses. So I'll recap the definition of predicates and clauses that we saw from the last lecture. What is a predicate? A predicate is any expression, any formula that evaluates to a true or false value. Here is an example. So that this is a predicate which has three clauses: x is greater than y, or c, or f of z. X, y, and z are some variables. We assume that they are not Boolean. X is greater than y will result in a Boolean value. C is a standalone clause, so C better be a Boolean entity. F of z is directly ORed with these two other clauses, so F of z better be a function that takes z and returns either true or false. So X is greater than y will be either true or false. C is a Boolean variable. F of z is a function that returns a Boolean value, so I can OR these three and get a true or false value for this predicate. Each of the three entities in this predicate are what are called clauses. A clause is a predicate that does not contain any logical operators, right? So now, before we move on and look at logical coverage criteria, I would like to spend a little time making you notice one point. So, as we saw in the last class, and even otherwise, you might know from logic that the same formula, well-formed formula, can be written using several different equivalent ways. And when we look at coverage criteria, the clauses and the way the clauses react could be different for each of the equivalent ways. But what we assume throughout this lectures where we deal with coverage criteria is that we assume that the given predicate will yield the same TR for a given criteria, no matter which form of the logical expression is used. For example, I could write A implies B directly using implies, or I could write A implies B as not A or B, but I assume that these are semantically equivalent, and as far as coverage criteria is concerned, I fix one of them and carry on. So here are some notations that we'll be using for the rest of this lecture and next lecture. We assume that we are dealing with a particular piece of software artifact. It could be code or it could be requirement given as a finite state machine, and that software artifact has a set of predicates. So we are dealing with a universal set of predicates that come from a given software artifact. Let capital P be that set. And C is the set of all clauses that come in the predicates in P. For each predicate P in P, the clauses specific to the predicate small p, we denoted by the set C suffix P, CP, right? So what is the set C suffix P? It's a set of all clauses that occur in the predicate P. C, which is the set of all clauses in the set of predicates P, is the union of all the clauses as they occur in each of the predicates in P. We deal with several logical coverage criteria. The first one that we deal with is the most elementary one. It's called predicate coverage. So if you see the English sense of this term, what does predicate coverage mean? It means cover the predicate. What does it mean to cover the predicate in turn? Predicate, as we saw, is any formula that results or evaluates to a Boolean value. So when I cover the predicate, I'm insisting that I give one set of values that make the predicate true and one set of values that make the predicate false. So predicate coverage says that for each predicate P in the set of universal predicates P, my TR or test requirement contains two requirements. One requirement insists that the predicate P evaluates to true, and the other says P evaluates to false, right? For example, if we take this predicate x greater than y or c or f of z that we saw in the previous slide, this whole thing is one predicate P. I want to be able to do predicate coverage for this predicate P, which means my TR says that there are two test requirements, one that makes this whole predicate true and one that makes this whole predicate false. Now this is my TR. So what will be the set of test cases that will satisfy this test requirement? Set of test cases that will satisfy this test requirement will be one for each kind of TR. So I need to write a set of test cases that will make the predicate true, and I'll write a set of test cases that make the predicate false. So remember, this is a OR predicate. So it is true if any one of these clauses in this predicate become true, and it is false if each of the clauses in this predicate become false. So to make it true, I can assign values for any of these variables such that one of the clauses become true. For example, here is one assignment of value that will make the predicate true. I have assigned x to be 5, y as 3. So 5 is greater than 3, x is greater than y. This predicate evaluates to be true. Remember, this is enough to make the entire predicate true, but for a complete test case we need to go ahead and assign values for all the other variables also. So here I have assigned c to be true and f of z to be false. So combining and substituting back these values, you realize that 5 is greater than 3, so x greater than y will be true. True will be ORed with c, which is true, which in turn will be ORed with f of z, which is false. So it will be true or false, which will make the entire predicate p to be true. Now I need another test case that will make this predicate false, because my goal is to be able to do predicate coverage. So here is such a test case. I assign x as 1, y as 4. So x is not greater than y. So this clause evaluates to be false. And I assign c to be false. So the second clause also becomes false. And I make f such that f of z returns false. So the third clause also evaluates to false. Since all three are false, the entire predicate becomes false. Here's a small observation. Now if you go back and look at the graph coverage criteria that we saw, predicate coverage has an overlap with graph coverage criteria. If you remember, we saw this edge coverage criteria when we did graph coverage, which was also called branch coverage. Assuming that every branch in a graph, every node corresponding to a branch in a graph is labeled by a predicate, predicate coverage for that predicate will be the same as doing edge coverage for that branch, because there will be one set of test cases that will make the predicate true, making it take the then part of the branch, and there will be another set of test values that will make the predicate false, making it take the else part of the branch. So there will be two edges coming out of the node that corresponds to this predicate, and it will mean edge coverage for each of these two nodes. So predicate coverage is the same as edge coverage. Now, what is the disadvantage in predicate coverage? If you go back and see this example, x greater than y or c or f of z, this predicate coverage tests this entire predicate as a whole. So, and if we look at the test values that we assign to achieve predicate coverage for that predicate, in both these set of test cases, in the first one and in the second one, we had assigned f of z to be false. So it so happens that we have tested predicate coverage, but we didn't really exercise the clause f of z being true. It could have been the case that there could have been an error in the software because the clause f of z was true. So it's not wise to just do predicate coverage and say I have given true and false values to make the entire predicate true once and to make the entire predicate false once and leave it at that, because we can do that as we did it in this example without exercising each clause. And you never know, maybe the clause that wasn't exercised for that particular value had an error in it. In this case, it could be the case that if f of z was true, maybe the software had an error. So it's not wise to just do predicate coverage. What we would want to move on is the next coverage criteria, which is called clause coverage. What does clause coverage say? Clause coverage is abbreviated as CC. It says for each clause in the set of all clauses, TR contains two requirements. That clause evaluates to true, that clause evaluates to false. So it says exercise each clause and make it true once, make it false once. That's what clause coverage is said to do. So if you see this example, it had three clauses, x greater than y, C, and F of Z. So what will clause coverage mean? Clause coverage will mean that you make the first clause x greater than y true once and false once. So I have made this true once because 5x, I have assigned x to be 5, y to be 3, and x greater than y is true. And here we have assigned x to be 5, y to be 6, so x greater than y is false. So I have made the first clause true once and false once. C I have made true once, false once. F of Z I have made two true ones and false ones. So this is a set of test cases that achieve clause coverage criteria on a predicate. So just to recap, predicate coverage says make the predicate true once, false once. Predicate coverage need not exercise all the clauses in the predicate. That is not desirable from the point of view of testing, because a particular clause that is not exercised for a particular value could contain an error. So we define another coverage criteria called clause coverage, which says you exercise each clause to be true once and to be false once. So that's what we did for this example. Now, just for knowledge sake, let's try to understand what will happen to the predicate for the first assignment of clauses. If you see, first assignment of clauses makes all the three predicates true. So the entire, makes all the three clauses true. So the entire predicate would be true. Second one makes all the three clauses false. So the entire predicate is false. So in this case, clause coverage also happen to achieve predicate coverage. The set of test cases that we wrote for clause coverage also happen to satisfy predicate coverage, but that need not be the case in general. Clause coverage in general need not subsume predicate coverage. The notion of subsumption is the same as that we saw for graph coverage criteria. We say one coverage criterion subsumes the other if every set of test cases that satisfy coverage criteria 1 also satisfies coverage criteria 2. So the claim now is that clause coverage does not subsume predicate coverage. Why is that so? Here is an example. Consider the predicate P is equal to A or B. It has two clauses, A and B, and here is the entire truth table for that predicate. What I have done is I have assigned true, false values to A and B, and in the last column we have tabulated when A or B will become true. This just happens to be directly the truth table for OR because we don't have anything else. Now let's say I want to achieve clause coverage for this predicate A or B, right? So I make each clause A and clause B true ones and false ones. So I choose rows 2 and 3 for that. If you see, in row 2 A is made true, in row 3 A is made false, in row 2 B is made false, and in row 3 B is made true. So between rows 2 and 3 I have made A true and false once, and I have made B also true and false once. So I have satisfied clause coverage by picking up these two values for A and B. Now look at the entire predicate A or B. For both row 2 and row 3, the predicate evaluates to true. So the predicate, I have not given a test case where the predicate has evaluated to false, right? So predicate coverage is not satisfied by choosing these two. So I can say, by using this as an example or as a counter example, to say that clause coverage does not subsume predicate coverage. In fact, for the same example, if I had chosen rows 1 and 4, which makes A true ones, false ones, B true ones, false ones, then I would have achieved predicate coverage. I would have made the whole predicate true ones and false ones. But the purpose of this example is not to illustrate that. The purpose of this example is to illustrate that it's possible to have combination of values such that clause coverage is satisfied but predicate coverage is not met. And these two values for rows 2 and 3 for the clauses A and B happen to be that. So in general, I cannot say that clause coverage always subsumes predicate coverage. It's wrong to say so. So the next one would be, because there are these combinations where some combination of clauses do not subsume predicates, the next one would be to give up and say you test for every possible combination of clause that can occur in the truth table of the given predicate. So that leads to a coverage criterion called combinatorial coverage, abbreviated as COC. So what does combinatorial coverage define? It says for each predicate P in P, TR contains test requirements for the clauses in CP to evaluate to each possible combination of truth values. So if I have, basically what it says is that given a predicate P, you write out the truth table for P, for each clause in P evaluating to be true or false, and then you test for the entire truth table of P. So if I have P is equal to A or B, there are 4 test cases that I give. I make A to be true along with B to be true, then A true, B false, A false, B true, A false, and B false again, right? And I test for all possible true false values of the clauses. Now, it's not too surprising to see that this might lead to a lot of test cases. In fact, if I have a predicate with n clauses, right, and because I'm testing against the entire truth table and the truth table has 2 power n rows, in the worst case, I will end up getting 2 power n test cases for a predicate with n clauses. That is an exponential number of test cases for a predicate with n clauses. In testing, we ideally would like the test cases to be as minimal in number as possible, but effective in finding faults if they exist. There's no point in testing it for exponential number of combinations of clauses and be exhaustive. Of course, this is like exhaustive testing, but it may not be possible to do exhaustive testing all the time, and it's not necessary also. What we are looking for are some kind of criteria that capture the effect of each clause on the predicate, and to be able to do this without considering all the combinations of clauses, right? Like for example, if we go back to this, it so happens that if I choose values for clauses A and B from rows 2 and 3, that combination of values didn't really affect the truth or falsity of the predicate. The predicate happened to be true in both the cases. But if I had chosen values 1 and 4, then I was effective in not only achieving clause coverage, but I was also effective in achieving predicate coverage. I chose different true-false values for each of the clauses, and as a result, I made the entire predicate true once, and I made the entire predicate false once. So that is our ideal goal. Our ideal goal is to be able to get criteria that capture the effect of each clause on the predicate, and to be able to do it without considering an exponential number of combinations. So the rest of the coverage criteria that we will be seeing in this lecture and in part of next lecture, goal is to achieve this particular point. So for that, we need to be able to understand the notion of a clause determining a particular predicate. So if you take this example, P is equal to A or B, let's say A is true, right? In this example, A happens to be true. If A happens to be true, because P is A or B, then no matter what the value of B is, the entire predicate P will evaluate to be true. Why? Because it's an OR, and there's one, for OR to be true, one of the operands, it's enough to be true. So we can say that when A is true, B does not determine P, which means irrespective of the value that B takes, P will become true. But let's say we consider the other case where A happens to be false. If A is false, now whether B is true or not will completely determine whether P is true or not. Let's say A is false, we parked it at that. Let's say B becomes true. Then false or true, P will become true. Now let's say with A being false, B becomes false, then P will become false. So if A is false, then we say that the clause B completely determines P, in the sense that the truth or falsity of B influences the truth or falsity of the predicate P, right? So this is the kind of combination that we would like to test. We would like to test each clause under circumstances where that clause determines a predicate. So how do we do it? We have to define what the notion of a clause determining a predicate is first. So we say at any point in time, given a predicate with several clauses, I focus my attention on one particular clause. The clause in which I focus my attention on is called the major clause at that point in time. All the other clauses are called minor clauses. So if I take, for example, this one, the first what I have made is that I say I want to focus my attention on the clause A. So when I want to focus my attention on the clause A, I make A the major clause. When I make A the major clause, B becomes the minor clause. And when I make A the major clause, I want A to determine P. For A to determine P, B should be made false. So at any given point in time, we are interested in one clause. We call it the major clause, and the rest of the clauses are called minor clauses. And then we test how this major clause that we have fixed determines the predicate P. After finishing this test, we pick up another clause from the predicate P, call that other clause that we have picked as the major clause, and the remaining clauses, including the one we picked up first, become minor clause. So each clause in turn will be treated as a major clause. So now we define the notion of determination. What is determination? Given a major clause Ci, I fix one clause to be the major clause Ci. I say that Ci determines P if the minor clauses Cj, which means all the other clauses, are such that changing the value of Ci changes the value of P. So if we go back to this example, if A is false, and A is a minor clause and let's say B is a major clause, then B completely determines P whenever A is false. So that's the definition here. We say a clause that we fix, call it the major clause, determines the predicate P if the values of the minor clauses are such that changing the value of the major clause changes the value of P. Please note that this does not mean that the major clause is equal to P. Neither does it mean that the truth value that P takes is the same as the truth value of Ci. Let's say the major clause is true. It doesn't mean that the predicate P also becomes true exactly when the major clause is true. It could be the case that when the major clause is true, the predicate is false. And when the major clause is false, the predicate is true. Or it could be the case that when the major clause is true and the predicate is also true, and the major clause is false and the predicate is also false. But what is important is that I fix one clause, call it the major clause, and say this clause has to determine P. Means whenever this clause changes its truth values from true or false to true, it will change the truth or falsity of P. All the other clauses, called minor clauses, take values such that this happens. And when this happens, I say that the major clause determines P. So using this, we define a few other coverage criteria. The first coverage criteria that we will be seeing is what is called active clause coverage, abbreviated as ACC. So what does it say? It says for each predicate P in the set of all predicates, capital P, fix a clause in P, call it the major clause, let it be clause Ci. And you choose minor clauses Cj's, all the other clauses, such that Ci determines P. Active clause coverage says, then there are two requirements in my test requirement for active clause coverage. It says one requirement says that the major clause Ci should evaluate to true, and the other requirement says that the major clause Ci should evaluate to false. Just to repeat what I told you in a different style, I have a predicate P. The predicate P has several clauses. I fix one clause that I want to focus my attention on. Let's say clause Ci. I call that the major clause. Now, the rest of the clauses are all minor clauses. I make them take values in such a way that this major clause Ci determines P. Now, my TR for active coverage criteria says that you make this major clause Ci true once, and then you make the major clause Ci false once. Is it clear? So here is the same example. P is equal to A or B. There are two clauses here, clause A and clause B. As I told you before, we take each clause in turn and make it the major clause. Let's say, to start with, I make A the major clause. So Ci in this table happens to be A. Read it as A is the major clause. I want A to determine P. So if A has to determine P, then B must become false. So B is assigned false here in the third column of the table. And now my test requirement for active clause coverage says you make A true once, A false once. So I have given that in bold. Now I'm done with A being the major clause. It's B's turn to be the major clause. So I say Ci is B now. Now for B to determine P, A should be false. And to achieve active coverage criteria TR, I make B true once and false once. Right? So this table, just to summarize it, each clause in the predicate takes turns to be the major clause. Here there are only two clauses, A and B. To start with, A is the major clause. So TR for active clause coverage says make A true once, false once. So I have made A true once, false once. And I want A to determine P. If I want A to determine P, I have to make B false. Similarly, when B is the major clause, A has to be made false and B has to be made true once and false once. If you see these four rows, they are not different. There is a repeat. In second row and fourth row are repeats of each other. Both in the second row and in the fourth row, both A and B are false. So I remove it. If I remove it, I only get three distinct tests. One that makes A true, B false, which is the first row. The second one makes A false, B true, which is the third row here. And the third one, which stands for the combined second and fourth one, makes both A and B false. So what does active clause coverage do? Active clause coverage chooses each clause in the predicate P to be a major clause, and then it writes TR, makes the major clause determine the predicate P, and writes TR, which says now make the major clause true once, make the minor clause true once. So that's the term active clause coverage. So let's say a predicate has several clauses. Each clause takes turn to be major, and the clause that is major becomes active in the sense that that determines the value of the predicate P. So I make it true once and I make it false once. And because I make it true once and I make it false once, it would completely test the predicate P, because that determines the predicate P. The predicate also would become true or false once and true or false once again, right? It so happens that for a predicate with n clauses, active clause coverage can be achieved by writing n+1 test requirements. Here it looks like we had 2n test requirements, right, where n is the number of clauses. So 2 requirements for A, 2 requirements for B. But as this example illustrates, one of it was a repeat requirement, so we merged them and we happen to get 3 requirements. So in general, for a predicate with n clauses, to get active clause coverage, it's enough to have n+1 distinct test requirements. So just a small point of observation before we move on. In testing, you might have heard of this term called MCDC criterion or MCDC testing. MCDC stands for Modified Condition Decision Coverage. It's a criterion which says that when I have a predicate with several clauses, you make each clause in the predicate become true once, false once, and test the predicate. Usually you switch off all the compiler optimizations, make every clause important in the predicate, and exercise each clause to be true once, false once, and test, and see how it influences the predicate. And you can go on modifying this condition. What is popularly called as MCDC is what we call as ACC, and MCDC is a mandatory way of testing for certifying several safety critical software. So now we come back to active clause coverage criteria. In active clause coverage criteria, we said you take one clause, make it the major clause, let the minor clauses take values such that the major clause determines the predicate. We don't really worry about what will be the values that the minor clauses will take. right? Will they take same values? Will they all take different values? We didn't really think about it. If you start thinking about the kind of values that the minor clauses will take, you can further refine active clause coverage criteria into 3 different categories. That's what we're going to do now. We will define it into 3 different categories. One will be called generalized ACC, the other one will be called correlated ACC, and the third one will be called restricted ACC. So we'll define each of them one after the other and see what they mean. The first one that we will look at is what is called generalized active clause criteria, GACC. What does it say? It says the following: for each predicate P in P, each major clause CI, choose minor clauses CJ such that CI determines P. This is the same as active clause coverage. I have not changed anything, right? The next sentence is also the same. I have not changed anything. TR has 2 requirements for each CI. CI evaluates to true and CI evaluates to false, right? Again, this is the same as active clause coverage. So far, no changes. This is the sentence where we begin to see the change. It says the values chosen for minor clauses don't have to be the same as when CI is true and as when CI is false. Basically, it says don't put any condition on the values that the minor clauses take. Let them be what they are. So in some sense, generalized active clause coverage is the same as active clause coverage. So one thing to be noted is that active clause coverage or generalized active clause coverage does not subsume predicate coverage. Why? Here is an example. Suppose you consider this predicate P which says A is equivalent to B. Now clause A determines P for any value of B. Right? Suppose B is true, then clause A will completely determine P, because A could be true or false and change the value of P. And if suppose B is false, then clause A still determines P, because A could be true or false and change the value of P, right? Suppose we chose the following test inputs. We make A and B both to be true and A and B both to be false, right? Then what happens for this predicate P, A equivalent to B? In both the cases, the predicate evaluates to true, because true is equivalent to true and false is equivalent to false, so it again evaluates to true, the entire predicate P. But this means that predicate coverage is not achieved, right? But I have achieved generalized active clause coverage because I have done A to be the major clause and B also to be the major clause. So generalized active clause coverage does not subsume predicate coverage. The next condition that we will see of ACC criteria is what is called correlated active clause coverage. Now let's focus on the English meaning of the word correlated. What does correlate mean? Correlate means that the minor clauses are such that they correlate with each other. So again, the first few parts of the definition are exactly the same. I take a predicate and I fix one clause, call it the major clause, choose minor clauses such that the major clause determines P. No changes so far. Second, again, no changes. TR has 2 requirements. The major clause evaluates to true, major clause evaluates to false. The third sentence is again where you begin to see the change. It says the values chosen for minor clauses must be true for one value of major clause and false for one value of the major clause. You go back, what does generalized active coverage criteria say? It says the values chosen for minor clauses need not be the same. Basically, it says don't provide any restriction on the values chosen for minor clauses. That's what GACC says. What does CACC say? It says that the values chosen for minor clauses must be true for one value of the major clause and false for other value of major clause. So we take the same example, predicate P, which says A is equivalent to B. What are correlated active clause coverage tests for P? Let's say A is the major clause. Then here is a test set for correlated active clause coverage. Please read this TT as A is assigning true to A and assigning true to B. Read FT as assigning false to A and assigning true to B. So I have made A as my major clause. A is true once, false once, right? So I have done this. And to make A determine P, I make B true once and true once again. So this will together determine CACC. Now if B is the major clause, B becomes true once, false becomes true once, and A remains as true in both the cases. Here again, if you see, A is true, B is true, A is true, B is true is common across these things. I don't repeat it, I put only once. So I make the three tests that put together that satisfy CACC are A true, B true, A true, B false, A false, and B true. In fact, we will show later in the next lecture that CACC does subsume predicate coverage. Remember, GACC does not subsume predicate coverage. And CACC does subsume, and I'll tell you why in the next lecture. The last active clause coverage criteria that we will be seeing is what is called restricted active clause coverage criteria. Here again, the first few parts of the definition are the same. I take a predicate, I take a major clause, choose minor clauses such that the major clause determines the predicate. We are here. Now, TR has two requirements for the major clause. Major clause evaluates to true, major clause evaluates to false. The third line is where the difference begins to show up. It says here for RACC, the values chosen for minor clauses must be the same as when CI is true and when CI is false. So we'll go back. We saw active clause coverage criteria. We are refining active clause coverage criteria into three kinds: general active clause coverage criteria, correlated active clause coverage criteria, and restricted active clause coverage criteria. What does general say? General says that the major values chosen for the minor clauses don't have to be the same. There is no condition. That's why it's called generalized. What does correlated say? Correlated says that the values chosen for minor clauses must be true for one and false for the other. That's why the term correlated. What does restricted say? Restricted says that the values for the minor clauses must be the same as when the major clause is true as and when the major clause is false. So it's restricted because it restricts the truth or falsity of the minor clauses to be the same as that of the major clause. Right? So since this is a little complicated, what I thought I will do is I'll take another example and explain active clause coverage criteria with reference to this example to help you understand it well. So here is the second example. Now you consider this predicate, read it as P is equal to A and B or C. What I have done here is I have given you the entire truth table for the predicate. So there are three clauses in this predicate, A, B and C. Each of these three clauses can take two false values in combinations. So if I put two values per clause, then I totally get 8 combinations of true false values as listed here. And the final column in this truth table says what will happen for each of the combinations of true false values of A, B and C. For example, if all three are true, which is the first row, A, B and C are true, then what will happen to A and B or C? It will be true. Why? Because B or C will be true, and true will be true. Now you take some third row here. It says A is true, B is false, C is true. But the result, the whole predicate becomes true. Why is that? Because even though B is false, false or true, B or C will evaluate to be true. That ANDed with A being true will give me true. Let's take another example. Let's take row number 6. It assigns A to be false, B to be true, C to be false. So because A is false and A is ANDed with something, the whole predicate becomes false. So this table gives the entire truth table for this predicate. Now what we're going to do is we're going to understand how the various active clause coverage criteria work for this predicate. We begin, as I told you, generalized active clause coverage criteria is the same as ACC, nothing interesting. So we will see correlated active clause coverage criteria for this predicate and restricted active clause coverage criteria for the predicate. So let's start with CACC, correlated active clause coverage criteria. So now I want to make A the major clause. which means what? I want A to determine the predicate P. For A to determine the predicate P, this must be true, right? Because if B or C is true, then if A is true, P will become true. And if A is false, P will become false. Now you look at B or C. B or C can be made true in three ways, right? You could make both B and C true. You could make one of B or C true. So in three different possible combinations of true false values for B and C, the predicate B or C will be true. So what I have done is I have pulled out rows from this row table, only those rows which will help you to get the coverage criteria of CACC satisfied. So CACC for A being the major clause can be satisfied by making A true once, which means choosing one of rows 2, 1, 2 and 3. Please see here, all the three rows A is true, right? And in all the three rows, there are three possible ways of making B or C true. So A and B or C becomes true. In rows 5, 6 and 7, A is false. A is the major clause. So I made it true in rows 1, 2 and 3. Now I'm making it false in rows 5, 6 and 7. Now again B or C is true in three different possible ways. In all the three cases, the predicate becomes false. So to get my test cases for CACC, I pick up one from the top set 1, 2, 3 and one set of values from the bottom set 5, 6, 7. Any of these will make A true once, false once, and B or C combinations are such that A will determine P. And they also satisfy correlated active clause condition, right? It says the values chosen for minor clauses must be true for one value of the major clause and false for the other. That is also satisfied in this. So to satisfy CACC for the predicate A and B or C, pick up one row from here, one row from here. How many different ways of picking up one row from here, one row from here exist? 3 into 3, 9 ways. So 9 combinations of 9 different test cases can be written to satisfy CACC for this predicate. Now for the same predicate, if you take A again as the major clause, and instead of doing CACC, you try to do RACC, restricted active clause coverage. In which case, what you can do is A is the major clause, so I make A true once, false once, true once, false once, true once, false one, and the values of minor clauses should be such that they take the same value. Right? You remember that they take the same value. That's what restricted active clause coverage says. So here if you see B is true and C is also true, B is true, C is also true, in which case A determines the whole predicate P. The whole predicate becomes true once, false once. Similarly here B and C take the same value such that A determines P. Again B and C take the same value such that A determines P. So here is how I satisfy RACC. So any of these three combinations, 1 with 5, 2 with 6 and 3 with 7 will satisfy restricted active clause coverage criteria on this predicate. So what are the logic coverage criteria that we have seen so far? We started with predicate coverage, most elementary coverage criteria. Make the whole predicate true once, false once. Then we moved on to clause coverage, which says for each clause in the predicate, make it true once, false once. We realized that they don't subsume each other. They can be completely unrelated. We saw examples for that. Then we say, okay, why bother? You take every combination of true false values of the clauses in the predicate. That will give rise to combinatorial coverage. Then we realized that there were too many combinations. There were in fact exponential number of combinations. It's not worth it. So I say I want to look at active clause coverage, where at any point in time I focus on one clause in a predicate, call it major clause. All the other clauses are minor clause, and see how this major clause determines P. And there are three different ways in which the minor clauses could take values. Those give rise to three different active clause coverage criteria. In the next lecture, we'll move on and define some more coverage criteria, and I'll tell you a little bit about how to actually get test cases to satisfy these coverage criteria. Thank you.